Welcome to this video tutorial about how to complete lab number 11400. We're going to be doing distances and angles in this lab. So looking at all the balloons that we have to output, balloon number 1 will be an angle from this surface here to the surface of the straight slot. Balloon 2 is a perpendicular distance from this angled surface back here to the center point of this hole. Balloon 3 is an angle from our secondary datum to this angled surface back here. Balloon number 4 is the center to center distance from this hole to this hole. Now note that that does not fall along the x-axis or along the y-axis. So we'll be doing a polar caliper distance for that. We also have balloon 5, which is the distance between this angled slot to the other end of the angled slot, and that one also does not fall along the x or y axis, so we'll be doing a perpendicular distance for that. Balloon number 6 is a 7-degree angle from the front surface to a line that connects this circle and this circle. And balloon 7 is an angle between a line that connects this circle and this circle, and another line that connects this circle and that circle. So we'll have to do some construction geometry in this lab, which will be a first on a couple different fronts. And then lastly, we have balloon number 8, which is a 40-degree angle from our primary datum, the top surface, down to this angled surface right here. So let's get to it and start compiling our points. So I'll start by creating a new measurement plan, and I'm going to go through the import process pretty quickly. We have covered that in other videos. So the easiest way to do this is to go CAD file, and load. We'll grab our cadcube.sat. And then I'll go planner, measurement plan simulation. I'll show the base plate, which is already visible, and I'll hit fit so that way I can see everything. I'll come over here to the modify CAD model window. I'm on the positioning tab. I'll go to shaded. I'll click on position, rotate. I'm going to click on the center checkbox here to make sure that I'm picking the center of whatever I click on, and I'm careful to pick on the surface that is at the bottom of the CAD model, and then I'll rotate and pick on the top surface of the base plate, and then I'll hit apply. Now that sounded like it crashed. No worries, we haven't actually programmed anything yet. If you did this in the real machine while you were connected in online mode, that would crash the real machine, so beware. So our part is positioned within the machine's volume now. Next, we'll do a base alignment, and this time we're going to do the technically correct base alignment. And this is important because we will be outputting angles, and a plane alignment is going to give you more precise results, particularly when you're outputting angles like the 7-degree, this 83-degree, 30-degree, and 40-degree. So we want to have a 3-dimensional view of what this part looks like. So rather than doing a plane line point this time, we're going to do a plane line line. All right. So I'm sorry, a plane. So datum A is the top surface. We'll touch a plane there. Datum B is the front. We'll touch a plane there. And datum C is the left side. We'll touch a plane there. We'll open up our base alignment window and accept the defaults by saying OK. We'll hit the pull-up menu here, and in some of the other videos, I've shown you how to extract features, define or select geometry, and we've done define line on plane, define circle on cylinder. An alternative approach is to click define points and let it automatically recognize features, which is not a bad way of doing it if you're using a CAD model. So I'm going to click 1, 2, 3 times while I'm on define points. That automatically recognizes a plane. I will say OK. We get spatial and Z origin. You do have to be careful when you're touching this as a plane that you do not touch the full extent of this. And the reason that I'm not using define select geometry is that will default to a scan path that will scan the entire surface of this, and we don't have the necessary length on the stylus for that. So when I touch my plane on the front surface, I'm going to touch a point up here, and I'm not going the full depth. I know that my stylus is only long enough to get just a little bit past the center line of this hole before the carrier crashes into the part. Now I could do 4 points, but the minimum number of points for a plane is 3, so I'll go with the best cycle time and we'll touch 3 points, trying to keep them as shallow as we can. We'll say OK. And then we'll come over, notice that our planar rotation and Y origin has been set by plane 2. And then we'll come over and touch another point, another 3 points rather, on the left side, and that will create our plane. We are again paying attention not to go too deep on that. You would not want to be touching points all the way at the bottom of that surface. You would crash the probe into the top of the part. Say OK to that. OK to the base alignment window. And our base alignment is all set. I do see that our base alignment right here has updated to where we want it to be, which is a good thing. We'll click on clearance plane, say clearance plane from CAD model, and OK. And OK. If the update clearance plane settings shows up, just say no. So in our features, we have a plane, and a plane. To keep this organized, we can click on the top one, hold Shift and click on the bottom one, and then right-click and say Form Group, and I will name that group. I'm going to right-click and rename it Alignment, or Align for short. Okay, so what other features do we need on this blueprint? Well, we are going to need, let's go by the balloons this time, just so I don't lose track of this while I'm making the video. We need a plane over here on the right side, or we could use a line. We will get better results with a plane, so we'll use a plane on the right side, and we need a plane over here inside of this slot to be able to output this 10-degree angle. Let's go do the 2 of those. So it's deceiving. Our measure points feature is still open here. So I'll come in here and go 1, 2, and 3 points, making sure that I don't go too deep on that surface either. That automatically recognizes that as plane 4. We'll say OK. We'll come over to the right side of this angled slot, and we'll go 1, 2, and 3, making sure that those lower points there are not so close to the bottom that the probe is going to crash into the bottom of that slot. We'll say OK. We'll worry about creating characteristics for these later. So we have what we need for balloon 1. For balloon 2, we need to know where this circle is, and we need to know where this either line or plane is. Again, I'll be doing this whole lab 3-dimensionally, so I am going to do this as a plane in the back. So we'll touch a plane on this back edge here. Touch points is already active. We'll touch 1, 2, and 3 points for a plane and say OK. We also need to touch this circle right here. For that one, we could touch points directly inside the circle and rotate around in between, which is totally fine. In fact, I'll do that for the first one. 1, 2, and 3. I'll show you an alternative approach like we've done in the other videos when we have to do this hole and this hole. That did recognize that as a circle. I'll say OK, and we'll worry about characteristics later. So by comparing the distance from that plane to that circle, we can output balloon number 2. Balloon number 3 is going to be the angle between that plane we just touched and our secondary datum, which is datum B. We've already touched our secondary datum, so there's no need to touch that again. We've already touched this surface as well, so we're good to go there. Balloon number 4 is the distance from the center of this circle to the center of this circle, and note that it is on an angle. So for this one, I'll use an alternative approach. Certainly, we could just define points, but we could also define circle on cylinder and click right there. Then we just have to be mindful to double-click on circle 2, come into strategy, come into our circle path. So I'm just double-clicking to get in all those. No matter what you have set here, you want to click on number of points. You want to set that to 3, and then you want to say single points. Now, this is actually the preferred method, even though it requires some more clicking. If you had to change this to more points because it was a more precise feature, you could very easily change this number, whereas the way that I automatically recognized it on this previous feature, it would be much more difficult to add more points, and they wouldn't necessarily be evenly spaced or at the same height using the method I did on circle 1. So I'll use the same method to find circle on cylinder for this last cylinder over here, or this last hole rather. We'll double click on circle 3, we'll go to strategy, circle path, we'll make sure its number of points is 3, and we'll make sure single points is checked on. Otherwise, the software will try to generate a scan path. So we'll say OK to all that. All right, so we have enough to output balloon number 4. For balloon number 5, we already have the right side of this slot, which we were using for balloon number 1. We need the left side of this slot. For this one, I will select Define Points, and I'll click 1, 2, and 3 points. Make sure that any points you touch on the bottom of this are not so deep they'll crash into the bottom of the slot. And say OK. Next, we have balloon number 6. Well, we already have this circle and this circle. We will have to connect a line between the two of those to be able to output this dimension. Speeding forward to balloon number 7, we have this 83-degree angle that goes between a line that connects this hole and this hole to a line that connects this hole and that hole. So we may as well create our constructed lines right now. This is new. These are called constructed features, so we're not going to be probing the part for this. We'll click on Features. Yeah, it's actually kind of deceiving. They're constructed features, but they're found under the Features menu. And you would think you could do 2D line, but this actually doesn't work. If you do 2D line and come into your options right here, we can recall features. But if I recall my features, it tells me that it's best to use a 3D line anyway. And I'll say OK, OK, and OK. And we see that it didn't automatically set itself to a 3D line. We want to get rid of that. And on the front side, we want to go Features and 3D line rather than 2D line. So we'll go 3D line because we need to come in here and recall features that we've already probed. So we're going to recall the results that we got from this hole and from this hole. And when we connect the center points of those holes, that will create the line that we want. So we created a line from the Features menu. We're coming into the Options pull down, and we will go Recall. We'll use our Feature Selection tool here to click on Circle 2, and then I'm holding Control on the keyboard, and I'll click on Circle 3 and say OK. I'll worry about doing the characteristics later. We're going to need that same line connecting this hole and this hole. So again, that's Features, 3D line. Double click to open, hit the pull down on Options and go to Recall. Here I'm grabbing Circle 2, I'm holding Control on the keyboard, and I'll grab Circle 1 and say OK. And OK. So now we have enough to output balloon number 6 and 7. Lastly, we have balloon number 8. We'll need to touch a plane on this angled surface here. For that, I am in the Select Points dialog. Now, we don't have to worry about going too deep on this. We won't hit the probe no matter what we do, just because of the shape of the feature. We could do 3 or 4 points here. I will do 1, 2, and 3 points, just minimum number of points for a plane, and say OK. Next thing is I want to run my simulation and make sure that all of this runs relatively path efficient, meaning we're not going way back and forth on the part, wasting time. Going from one corner to the other corner, so we may have to reorder some of these things. I'm also going to make sure there are no collisions. To do this, we'll go Planner, Measurement Plan Simulation. The big thing is that you got to have collision observation on. If that window is closed, it is not checking any collisions. And then we'll grab our speed slider. We'll go all the way down, +1. We'll grab all of our features here and we'll say Run. We'll clear existing results. We are going to go with our named alignment. We'll do our current selection, features list, clearance plane, slow through first feature, and 55 is our standard for when we're running simulations. We'll hit start. Now you'll notice I was clicking around on some of these settings to get that plane to go away from the top. That way I could see what we're doing a little easier. We do have some odd clearance planes here. I'm paying attention to the depth that that's probing at, making sure that the retract values are not hitting the opposite side of that slot, making sure that the carrier is not going to hit the top surface of the part at any point. I'm also making sure that the depth that these holes are probed at is not so deep that the probe crashes. The holes can be particularly slow, so I'll speed that up just a little bit. I'll show you a setting where we can turn arc motion mode off to make hole probing a little bit more efficient. But so far, looks like we're pretty good. I didn't notice any obvious path inefficiencies. We certainly could reorder some of these features, but that takes time, and if it's not that egregious, if it's not that big of a deal how far it's traveling, I'm going to elect to skip it this time. I will come into the Measurement Plan tab, and I'll go to Measurement Plan Editor Features. And this is a standard. We'll go to Travel, Clearance Group, and I have some of these that are not set to +Z, so I'll grab everything, and I'll go CP +Z. It's probably also a good idea to come into Clearance Distance, make sure that that is defined at 0, so I have everything selected. I type 0 and hit Enter. Notice that all the text turns black, which is what you want. And then we'll come into Retract Distance. For the first 3, I like to set those to 1/4 inch, so that way we can find the part. And for everything else, I'll set that to 50 thousandths. For arc motion mode, this is what was causing those holes to be simulated slowly. I'll grab that and turn that off for everything, say OK, and we'll go back and run one more simulation just to make sure all the changes I made there are correct. In the Features tab, grab everything, hit Run, and Start. If you want to turn this plane off so you can see a little easier, toggle from this back to this. So those two settings are, what are they called? Show CAD model and only show selected geometry features in CAD. All right, so everything is looking good here. See, those circles are simulating much faster now that arc motion mode is off. There's one area where we could improve the efficiency. We could put the plane on the right side and the plane on the left side closer to each other. I'll save that for a different video. You're certainly welcome to do that on your file if you'd like. But we have a file that runs with no collisions, so I'm going to segment the video here, and I'll meet you at the characteristics.